So my name is Lighton, and this is strange. This talk is not. Okay, it's okay. So the title of my talk is leveraging AI for effective and efficient radiological workflows. Just to mention here that I'm giving this talk as on behalf of my other colleagues. So the work I'm going to talk about is a collaboration between three entities: the University of Zambia, the University of Cape Town, and we partnered with radiologists at the University teaching hospitals. This is going to be the outline of my talk. I thought I had 15 minutes, which is why I decided to do a bit of marketing. So in October, we have an event that is going to be hosted by the University of Zambia. It's the 27th International Symposium in Electronic Thesis and Dissertations. Deadline is 7th of June, which is tomorrow. But by the time zone is anywhere on Earth. So technically speaking, it will be somewhere around, I think, 14 hours Kenyan time. You probably want to submit an abstract. The deadline is abstract submissions. Details are on the website. But the idea behind the event really is centered around electronic thesis and dissertations. And it turns out that the theme is somewhat aligned with what we've been discussing at DSA. You notice that there is an AI component towards this year's theme. Ideally, the event is hosted or organized rather by an entity called the NDOTD. And of crucial interest perhaps is the fact that this year's event is primarily aimed at trying to make sure that online visibility of ETDs coming from places like Africa is increased. You probably want to find time to take a look at the slides. There are links to interesting statistics like this map, for instance, and this tree chart right there. Africa is on the bottom right there, which is quite negligible. Also, I happen to be a founding member of a research group called the Data Lab Research Group at the University of Zambia. And part of what we do is we actually conduct research that is centered around anything to do with data mining, with a specific focus on machine learning techniques, ideally. So over the last 4 or 5 years, we've been trying to figure out how we can try and solve this problem right there, right? The same problem has been visualized in certain interesting ways. So this is a distorted map of the African continent. You notice that in terms of scientific publication, apparently research coming from the African continent is quite negligible. We've done quite a bit in this space. Again, I'll draw your attention to the publications at your own time. You probably want to look at some of the things that we've done to do with machine learning. So we built models that are meant to, automatically organize content, to try and automatically generate tags, with the ultimate goal of trying to increase the visibility of research. Also, of late, we've started looking into this issue of Wikipedia. The fact that if you look at the content on Wikipedia, there's actually very little content on and about Africa. And in fact, the little content that is there is largely, right, contributed by people that are not actually from Africa. We've done studies in Zambia, which have actually demonstrated this, by the way. Just to also mention that in case you're wondering why we should obsess about Wikipedia, these so-called large language models that we've been talking about here, in part we use content coming in from such platforms. So I think GPT-3 it was made use of about 3% of the data used to train GPT-3 is coming from Wikipedia. I'm not sure about Kenya here, but this is a huge problem in Zambia. All right, so my talk really is tied to a much larger project, which we called Enterprise Medical Imaging in Zambia project. And our goal really is to, we're trying to figure out exactly how we can make radiological workflows, anything to do with radiology, more efficient and effective. The motivation stems from the fact that Zambia, as of 2021, it was, had about 9 radiologists. Right about that time, the population was about 18 million. If you do your math, or your arithmetic, you notice that it's 1 radiologist for every 2 million people. Now, we're not saying that we're trying to solve that problem, but we're trying to see if we can, come up with solutions that can address some of the problems that arise as a result of that issue there. I took the liberty of taking statistics from some other African countries. You notice Kenya is somewhere here. As of 2020, apparently, Kenya had, sorry about that, is it 146 radiologists against a population of about 53 million? If you do a math, that's about one radiologist for every 368,000 people. The question you should be asking yourself is, do we have radiologists in all the health facilities in Kenya or in these African countries? Okay. It turns out that in the case of Zambia, these so-called radiological workflows, right, are predominantly manual in nature. And this is part of the reason why we embarked on this project, to try and see how best we can automate some of those activities in the workflow. A bit about your typical radiological workflow. I'm calling this Radiology 101. But ideally what happens, in case you don't know, when you go to the hospital and the physician who's attending to you realizes that an examination needs to be conducted, the process actually begins with a request. So the referring physician will request for an exam to be conducted. Typically, depending on whether you have the necessary systems in place, a schedule will be prepared, right? So that the radiographer or the operator can then perform the examination, right? So an image will be generated. After that, that image is going to be taken to the radiologist, who then does interpretation. After the interpretation, the radiologist will then generate the report. Now, in the case of Zambia, the entire end-to-end process here is manual, right? The problem with that is that obviously the turnaround time between a patient being attended to and a report actually being generated is lengthy. Okay? And so what we've decided to do, our research, by the way, is situated within public health facilities. We are alive to the fact that a number of these private health facilities will probably have mechanisms in place to address this issue, like teleradiology, for instance, right? So they'll subcontract the services of radiologists from outside Zambia to do the job. I believe the same applies to Kenya. And also, perhaps this problem may not affect the vast majority of people in here, is it? We are the privileged few here. But think about people that are in these remote places. Okay, so this was the context. So this is the context of our project, right? So the dots represent the different sort of health facilities, and our specific focus is on health facilities that we will have modalities. So a modality is essentially the equipment that is used to generate either your X-ray, your CT scan, or MRI, right? Quite a number of them. Okay. There's details, by the way, about this graph here in the paper there. So in essence, what we are trying to do, what we set out to do, is to take advantage of what's called enterprise medical imaging. And the idea behind enterprise medical imaging is it's a series of strategies and technological interventions that aim to streamline your typical radiological workflow. Our scope of work is restricted to the 7 work packages that I've listed there. So we're looking into, how we can devise policies to try and solve this problem. But also, we are trying to see if we can set up the necessary technological infrastructure to try and address the problem. So we've implemented a PACS that is soon going to be deployed. At least we know for certain that by the time we are wrapping up the project, it will be deployed at least at the invest teaching hospitals. And then we've done extensive studies centered around trying to assess DICOM compliance. In terms of the specific things that are tied to the funding that we got from Data Science Africa here, they're tied to work package number 2, 3, and 6. I'm just going to cruise through because I think I have 2 minutes left. So everything we've done to do with, data mining or AI-centric solutions of sub-problems that we're looking at make use of the CRISP-DM model. I'm not sure if this has been discussed in some of the talks that we had from Monday through to Wednesday, but the idea is you have this 6-stage process which helps you execute a typical data mining project. We'll cruise through that. That's very important. So in terms of what we've done by way of automating the process of storage and management of images, like I said, we've set up a base infrastructure. So it's typical picture archiving and communication system platform. What it's used for, ideally, it's used to store, manage, and enable access to data. The beauty for us with this is that it will make it possible for us to do the more interesting AI stuff because we have the base infrastructure that is used to store these images. Something else that we have done is we've devised models that are aimed at trying to automatically classify medical images. The idea behind this is that you typically have a lot of images. So a typical health institution like the University Teaching Hospital generates thousands, if not millions of images in a given month. The question to ask is, how do you find what you're looking for if you're a radiologist or a radiographer, if you will? Something else that we have done is we've built models that are aimed to assess the compliance of the DICOM standard. The idea behind a DICOM standard or a DICOM image is that the descriptive auxiliary information is actually embedded within the medical image itself, similar to how metadata is stored in your typical image, right? You have GPS coordinates, for instance, tagged to that. So we've done analyses that are aimed at trying to demonstrate that crucial critical information is actually omitted from here. And I guess the more interesting stuff to do with AI is we've developed two models, so a pneumonia detection model and a pneumonia classification model, which primarily is aimed at trying to demonstrate that we can actually build models that take advantage of what was introduced as a human-in-the-loop approach by the keynote speaker. A demo is available. One of the students I'm working with now is around, should be able to show you exactly how it works. I think what's interesting for us was the demonstration on the efficacy of this particular solution. In particular, what this graph is showcasing is the implications on the workload of radiologists. We've also done user-centered studies that are aimed at assessing the perceived usefulness of the solution. I think I've run out of time. Thank you very much. Just to mention here that some of the things that we ought to be thinking about here to do with policy, interesting entities like the Oxford Institute have done studies that seem to suggest that there's a bit of a problem here in terms of AI readiness for most countries in Africa. I do hope that during this workshop, we can probably have conversations centered around this, and of course, details to do with the many strategies that a number of African countries are devising. Thank you very much.
Oh, thank you. My first question, as we think, you have deployed this in some health facilities?
So what we have developed is, I spoke about three main things here. What we deployed it per se, not fully. So we have, I guess, partially. So we've deployed the PACS platform, in part because we're taking an agile approach. And so what we've done is we've hooked it up to one modality, right, which is used to generate X-rays, if you will. So radiologists are actually in the process of using it. And the thinking behind this is they'll be able to give us feedback on how best we can improve this platform. But in terms of the AI model, for instance, that I spoke about, no, that has not been deployed. It's ideally meant to set the stage for other interesting things that we're doing. Yeah.
Yeah, thank you very much. Thank you very much. You didn't have a lot of time to make your presentation, but it was interesting. It was interesting. Can you tell us about your success rate in terms of using AI solutions, the AI solution that you talked about, to solve your lack of radiologists? I was very shocked you have only 9 in Zambia. That is one question. Second question is, who owns the solution that you have developed? Who owns the data? Who has access to that data? To what extent does the government of Zambia have access to that data and can analyze it for all kinds of decision making in health in Zambia? Those are my questions.
Right. So I'll start with a very important question of the success rate. It turns out the success rate is implied. So what we're saying is that if you were paying attention when I was talking about, when I was cruising through this radiological workflow, I mentioned that one of the major issues is to do with the turnaround time, all right? Because this is manual, the time it takes, there's a lot of time, right, taken for the request to get to the operator for the examination to be done. There's a significant amount of time spent by the radiologist interpreting the medical images. In fact, there's also quite a bit of time involved to actually draft the report. And so with a semi-automated approach like this one, you're ideally reducing the amount of time that a radiologist would be interpreting the medical image, because you're, integrating an AI solution. So as opposed to it taking, let's say, 10 minutes to do the interpretation, maybe it will take half the amount of time. The other things that I didn't talk about, which is being overseen by our colleagues from the University of Cape Town, is to do with reporting. Drafting of the report does take quite a bit of time. And so what our colleagues from UCT are doing is trying to see if they can devise solutions aimed at automatically generating these reports. Again, reducing the amount of time it takes to actually produce that report. In terms of the data, currently the data is owned by the university teaching hospitals. I know that there are a number of MOUs that have been signed in regards to entities from outside Zambia gaining access to the information, but the information the data that is currently being used as part of the project is actually owned by the university teaching hospitals.
All right, so full disclosure, I'm an employee of Google, but I'd like you to share, and I think this may clarify some pieces that you may think, like so Google is a funder, it's a big tech. What does that mean for your project? Do you have to give Google data, or what is that?
I know. So, see, one of the most interesting findings we've gotten so far, the fact that there are no strings attached, actually. It's part of Google's award for inclusive research. And so the only thing that Google asks for is attribution, actually, that they've funded the research. So at no point has Google requested that we share any sort of data that we're using as part of this research.
Thank you, Lighton, for this presentation. I appreciate that this has to do with a work package that you are probably not yet at, but how do you anticipate mitigating the challenges that might arise when you're trying to manage the perception of the applications as far as healthcare workers are concerned? In fact, this question, I thought about it as well during Rose Lakasi's presentation, because beyond the skepticism, I think there is a certain level of fear among healthcare workers about potential job losses.
Oh yeah, we've actually had so as part of the work we've been doing, we've been engaging with radiologists, key stakeholders, and you're right, actually. There's this misconception, misrepresentation of what AI is going to do. My take when it comes to healthcare is that for now, I think we can't completely do away with the health workers, and we've made that abundantly clear that the solutions we're proposing are meant to complement what they do. So we're not taking away the human being from the approach, but rather complementing what they do with the AI solution. We are yet to finalize the survey. It will be interesting to see exactly what sort of results or what we get in regards to the perception, because it turns out that in terms of uptake, when it comes to AI, I think there's a bit of low awareness in the Republic of Zambia.